Welcome to Haxby Shed and the Shaper Miller project, part 3. Bit warmer today, about 13, 55 Fahrenheit, so I can dispense with the funky orange overalls, which are mostly to keep me warm. We need to think about what we're going to do with this axis. This way and this way look after themselves really. It's already built into the Shaper. Now, the slot on the top of the Shaper here is about 6 inches long. And the ram is positioned at about the furthest back that it's going to be with this milling head on, which will give me a cutter somewhere about here. Now this table is 9 inches long, and so if I pull this forward, it's obvious that it's going to be 3 inches short of movement. Ideal. There we are. So I really want it to come to about there. Now then, obviously I've got to set it and then lock it. I could arrange some kind of lead screw with a dial and an indicator, and I could put it in the back here so that I could just turn the dial and it would adjust the position of this ram and where the milling head is on the table. Well, that's a bit complicated for the moment. I want to be able to test this and make sure the whole setup works properly before I invest time in anything like that. And even then, I wouldn't make the screw and the handle and the dial and so on. I'd just find one somewhere that I could adapt, probably, you know, car boot, auto jumble or something. So what I'm going to do is I'm going to put a fixed rod between this position, where this big nut is, and back to the wall. And then I might put an adjuster screw in it so that I can get those extra 3 inches on the travel. That's the idea. Now, I'll have to put this into gear, so to speak, turn the handle, move this about a bit, fiddle around to set the distance that I want when I'm setting it up. But I think it'll be fine. Now, I won't be able to say, well, I'm going to cut a slot and then I'm going to index over some fixed distance and cut another slot. I'd have to manually set that up. But how many times do I really have to do that? You know, this isn't going to be a Bridgeport miller. It's a Shaper with a milling head to do 90% of the jobs that I'd want to do. And it's only going to cost me 150, 170 pounds, you see. So you might say, yeah, but hang on, you know, what if the distance between here and here changes? It'll move the position of the ram. Well, that's right. If there was an earthquake, you know, that position could change. But if there was an earthquake, there might be other things we have to think about. And you might say, well, what about thermal expansion and contraction? Well, not in the 10 minutes I'm going to be using it. So I'm looking for some kind of rod or pole that I can use. So I've got this part of a kid's swing that I saved. It's already got a flat on one end. I can put a bracket on this wall. I can put a loop on this end. I've got some parts somewhere. A Volkswagen car suspension, 14mm fine thread bolt, about 100mm long. Some big nuts to go on the end. I could force them into the end of that tube. I could maybe TIG weld that. With it cut, this in the middle, this is what I'm talking about, this sort of in the middle, so I can adjust the length of it, and you know, that might be what we need. So that's the approach I'm going to take. I'm maybe going to make it without the adjustment first and then add that in if it seems to be working okay. Let's do. The piece of metal that I've chosen for my wall bracket was a rough bit of angle iron, and it was flame cut at one end, so I'm just cleaning it up. That looks better, tidied it up. I'll use this expanding bolt to put the bracket on the wall, so I just need to drill a 10mm hole in this bracket here. Half-inch hole for the top of the ram. 8mm. Well, it's taking shape. Bracket, strap, wing nut, adjusting screw, weld that on there. I expect most people know about SDS drills, but in case you don't, they're a lot more powerful than a standard percussion hammer drill. Drill that out at 12 and then follow up with a 16. That'll do. It's actually gone into the mortar bed. I would have preferred it into the brick, but that's just where it lines up. I'll just try and create a bit of a flat pad for this to go onto, because obviously the bricks are all over the place. Huh. What did I say about clamp bricks the other day? They just break up. Well, this is going pretty well. Next, a bit of welding. As I get a bit more experience, I'm finding that I can manage without any filler wire. I really don't know what's happening with my TIG welding. I spent weeks not being able to do anything, and then all of a sudden I seem to get a breakthrough, at least on this thick stuff, and I've welded that without really any filler wire at all. Well, I'm going to try and tack this, but it could be difficult. The nut is pretty thick and the tube is pretty thin. Lots of quick work and daubing, a few tungsten dips, but it's worked. With a bit of cleaning up on a wire wheel, and I machined this here on the lathe just to get it nice. I've tigged the head of this screw to make it captive on this plate and painted it with red lead. I don't think we call it red lead anymore, do we? That's what they used to call it. Red oxide paint. And I've mixed up some sand, cement and lime just to create a little bed for it. Because I chopped away at this wall to try and make it sit flat. If I've got this right, if I set this screw adjustment to the mid position and I set this to the middle of this slot, the bracket should line up with the middle of the table. That's it. Thinking to the future, if this milling head works okay, and I decided that I would fit a lead screw to the back of the ram, you know, with a dial, I wouldn't be using this restraint bar that I've just made. So to hold the ram in place and to lock it, I could cut this gib strip, say there and there, and make this section here into a clamp. I'd drill through and then I'd drill into the body and tap it, just like these screws here. And I'd have two screws in each section, that section and that section, to hold them into place, and that would retain the ram. And I'd just have a little handle here as a clamp. I think that would work, but that's kind of stage 2 if the milling head works okay. So we'll wait for that thrust bearing to come, then I'm pretty much finished, and we can do some test milling and see how well this is going to work. I'm probably going to move that cable around to the other side. I think I will put the inverter on the wall to the left of the shaper. I'll probably put on a 3-phase plug socket connection, one of the red ones, and put one on the end of the milling head cable and also one on the end of the welding rotator cable. So that'll give me a versatile setup. It means that I'm going to have to change the parameters on the inverter as I swap the motors over, but I won't be doing that very often anyway. Let's check the motor spindle first. I'm just spinning it by the fan on the top. That's showing a deviation of 4/100ths or 1.6 thou, which isn't bad. Now, I haven't pushed that chuck on fully yet. We haven't got the thrust bearing in place. All that would help. If I pull on it, well, I get a bit of movement there. If I pull on the whole head, I'll just zoom out for that. I can tug and tug and tug and get about 5 or 6/100ths. And that's if I really pull on it. And sideways there's nothing. Here I've set up the gauge on the bottom end of the bar here, and I'm going to wind the top slide down and we'll check the deviation over this length. Now you can see it's moving down there. So over that distance, we've moved about 17/100ths of a millimetre. And you might say, well, that's awful. Well, I do get a bit of deviation there, but remember, no thrust bearing yet. And the chuck's not secured fully yet. But you might say, well, that's awful. Well, actually it isn't awful. I'll tell you for why. And that is, I've got a bit of a lump on the back of this plate where it secures onto the top slide, down slide. I need to machine it anyway a bit. Luck is on our side, and the deviation's, going in the right direction. Well, it's taken a bit of time to get this right, but we're showing 0, 0. This is pretty good. Now what will happen is it'll start to rise as it comes to this bump. There we go. And then it'll start to fall. Ooh, it's gone a long way there, hasn't it? I think Shapers look good from all angles. It can't make its mind up between 1 click and 2 click. I've got it, 2 fine, but I don't want to stop it now. Shapers are ace, I think. Now you might be wondering whether it was worth all the trouble to machine the back of here, just to get it at 90 to the table in this direction. I could have packed it, couldn't I? But that wasn't the main issue. Because this plate was not flat, when I tightened up these 2 screws really tightly, this slide got tight. And the screw isn't touching this thread, because it can if it's too long. I think it might have been distorting this casting, and because it was cast iron, well, that's dangerous. So that's why I put the time into this. Now there's no spring in this plate as I tighten it up, and I can move this as freely as anything, so that's good. Thrust bearing has arrived. Scratching my head a bit about this seal stands proud of this. This bearing is not very big and it sits mostly on the seal, so it's not very far onto this collar surround here, which means the bearing's not supported in the middle. I could have bought a wider bearing, still with a 15mm hole in the centre, but it was taller and I didn't want to give up height. Doesn't matter for the table, it's just more. I didn't want to give up height in here. I wanted full engagement. This plate needs to come off so I can investigate. These surfaces are unmachined, so I don't know if they're true anyway. I've actually managed to get the seal out without damaging it. The recess here is 7mm and the seal is also 7mm deep, but I can't get the seal to bottom in here at the moment. Anyway, what I'm doing now is I'm checking this face to see if it runs concentric with the back face here, and although the needle's flicking about a bit, That's just dimples on the surface. It's to within 1/100 of a millimetre, so I'm happy with that. So now I want to check these unmachined surfaces and see if I need to machine them. Well, I'm just trying on this inner collar here, and it's pretty clear that I do need to machine it. I've machined this face and this face, and they should be in the same plane exactly as this face now. But I've also machined some of this web away at the back of the oil seal recess, about half of it actually. So the depth of this recess now is about 7.8 millimetres for a 7mm oil seal. So I should be able to get that oil seal right sunken into here. But I've also relieved the hole for the oil seal because it was a bit tight. Aha! That's how it should have been in the first place. With that seal sitting below that face now, it exposes part of the shaft which is 15mm diameter almost, and it acts as a perfect retainer for this bearing. And when I slip this collet chuck on, without a key for the moment, the spindle is just proud inside. You can't see it, but trust me it is. So I'm using a wave washer, a big washer, and I can put this screw into the end of the spindle on the motor, tighten that up, and it just puts a little bit of pressure onto that thrust bearing there, a sort of preload. I'll be able to put a bit of Loctite on that screw, and that's pretty much it. Now what I'm going to do is make a shield for this bearing to keep it enclosed. There was just a little bit of fitting to do on the key actually, so now it's fine. Well, this is it folks, the first test of the Shaper miller. I'm going to do something really easy. I'm just going to trim the edge of a piece of brass. It's a job I could do on the Shaper quicker than this. I've not clocked the vise. I'm going to run at 50 Hz, which is 1390 RPM. I've not secured the ram. I'm just going to rely on the ram's own weight. We're just going to see if it works. Well, you saw me milling that strip of brass, and to me it proves that this is going to work. And over the last week I've been working on little improvements here and there, and one thing I realised was that when I put the screw on the end of the motor shaft in the bottom of this chuck here, the screw was actually impacting the bottom end of the collet, and I was getting some variable results with the work appearing to wobble like that, and I couldn't understand why. So it took me a while to figure that out. Now, to avoid that problem, this chuck needs to be further out. I could put some washers in here, but actually what I've done is I've bought the larger bearing. So it's still 15mm in the centre. I think it's 32 on the outside, but it's 3mm taller. Now, it was only £3.50. When I looked at these, I thought about buying both at once. That was £2.50, this is £3.50. That's about $4.25, I guess, US, something like that. You might wonder, how did this come about? Look at the gap there between the key and this. Well, it happened because this shaft has moved further forward, because I had the wave washer for the motor bearing on this front bearing, and I've moved it to the end bearing, so this moved all this forward. And then I started to get the problem with the screw touching the back of the collet. This bigger bearing is much better because it sits right to the edge of this supporting collar. Well, I've finally got this to the point where I'm happy with it. It's taken about half a day. Now I know that the milling head is going to work, I'm just doing a bit of work to improve the accuracy. And this does not sit exactly square to this vertical plate here. And I need to take about 1/10 thou off at this side relative to here. So I've got it in the big vise, got the parallels in, I've got some feeler gauges in here, just to lift this end slightly. I've clocked it. It's taken a fair bit of time to set up, but now I'm just going to carefully machine across this face to take 1/10 thou off this edge. It's about 10 days since I first did that cut on this piece of brass, just along this edge here. And since then I've been working to improve the accuracy overall of this thing. And I can now get it absolutely vertical in this plane and in this plane to the limit of my patience, really, setting it up. I have to say thanks to Alan, who gave me this 12mm carbide end mill. In fact, he gave me two. Right, I'm going to try and cut a pocket in this old piece of scrap angle iron plate. I'm running this at 800 RPM. See what happens. Right, this should be 1mm this time. Well, a fair bit of chatter. It's not liking it very much, is it? I'm going to have to come up with some kind of collar or bearing here and then mount it off this face. Here's the bits that I'm going to use to put on a lower support here, a collar around here. So 100mm or 4-inch bright mild steel. So that'll be to make a circle here, which will index into this recess. Piece of scaffolding pipe, which will form the main body of the support. And then this bronze bush, which came from my Rapidor. It was the main bush off the Rapidor, which was oval at one end, that end that you can see there, but is round enough at that end. And with just a scrape inside, it's about 31.75mm here. And that'll go over this, which is 32. So that'll give me a bronze support bush right along this here. Now, don't know what I'm going to do about this because there are the flats that I need to get to tighten the collet. I may just have to do something else instead. That's secondary. I'll figure something out. I'm going to take a 10mm slice off this, a bit more than I need, but it just covers me in case this doesn't cut completely vertical. First use of the machinist jack that I got from the Autojumbo, so that's very useful. Checking the level here on the bed and then checking the level here, so I can see that's about the same, and I've put a little wooden packing block over it this side. So we'll set this going, come back in a few days and maybe it'll be through. I'm just doing the finishing cut on the second side. It's only bright mild steel, so it's difficult to get a good finish. So I'm using a round-nosed, high-speed steel tool. I've got to machine a step on here so that it indexes into the bracket. But I'll have to bore this when it's all cleaned up and everything from the other side. So what I'm going to do is I'm going to machine that step now, somewhere here, but I'm going to drill and ream a 14mm hole in the centre because I have this exact 14mm plug that I made for something else. I'll be able to locate this in the hole when it's flipped round, clock off this in the forejaw and get it set up exactly concentric to this step I'm going to machine. Oh, and if you're wondering why I'm going to that trouble, well, it's because with a 3-jaw you cannot guarantee to get something back on centre. If you do all the machining from one side, it's fine, but flipping it over with this chuck, I could run out between about 3 and 7 thou, depending on just how I clamp it. The only way to be certain to get something dead centre is on the 4-jaw. Perfect. So when I set it up in the 4-jaw, I'll clock off this, and I'll know that this will be absolutely concentric with the centre. Here's a tip, folks. Don't drop a BMW gearbox on your finger. My son and I were taking that old gearbox to the tip, 80 kilos, and we had to lift it over a high rail to get it into the skip. And somehow, you know, we balanced it on the rail with my finger underneath it. So, you know,